Let's minimize the surface area of a right circular cylinder. Yay. So a right circular cylinder with no top. Oh, well, there you go, no top. Has a volume of 50 cubic meters. Find the radius that will yield the minimum surface area. It says let x equals the radius, but I like r. So I'm going to let r equal the radius. Be a rebel. Now, okay, so it says that there's no top, and it tells us the volume of the cylinder. So first of all, we need to know what the volume of a cylinder is. The volume of a cylinder is simply pi r squared times h. All right, so the radius of the cylinder in this picture is basically just going to be the radius of the circular portion at the top, and then the height of that cylinder here is going to be, let me see if I can make that a little bit neater. The height here is going to just be the vertical height, all right? Now, it tells us that the volume is 50 cubic meters or whatever it is. It doesn't really matter, but 50. So I'm going to plug that in, and there's really nothing else I can do with the volume, all right? That's kind of it. So now what I'm going to look to do is I'm going to look to the other piece of information in the problem. It's talking about surface area. Now, what is the surface area of a cylinder that has an open top? Well, if you were to think about it, imagine it's a cup, basically, right? I mean, it's a cup. It's a cup, all right? A regular old Solo cup. Yeah, Solo cup. Yes, I said it. Yep, red Solo cup, by the way. You ever hear that song, Red Solo Cup? I fill you up. Let's have a party or something like that? I'd sing it, but I can't sing. But for some reason, that song just popped into my head. If you know what song I'm talking about, leave a comment below. Anyway, red Solo cup, I fill you up. Okay. So now what I want to do is think about what's the surface area of the cup. So you have a bottom face to it, right? So there's some area here for the bottom, and then the sides, right? The side of that container also has some surface area, but there is no surface area attributable to the top because, well, it's open. So what I can say is that the surface area here of the cylinder is going to be equal to the surface area of the base, which is just a circle, right? So it's the area of a circle, plus then the area of the side. Now that might be a little bit hard, but imagine you took the Solo cup and you took a scissor and you cut down the entire front face. Now imagine it's not plastic, so you're able to kind of unfold it nicely, okay? If you were to unfold it, it would actually unfold into a rectangle, interestingly enough. And what happens now is that the length of that rectangle is actually equal to the circumference of the circle, right at the top or the bottom. Okay, so that's the circumference. That's this, if you were to unfold it. Okay, and then, the height of the rectangle is really the width. So this is kind of still, this is the height on that side. So to find the area, you know that the area of a rectangle is simply going to be length times width. So in this case, it's just the circumference times the height. Now remember, the circumference of a circle is going to be 2 pi r, all right, or pi d. It doesn't, times the diameter, but it doesn't matter. But in this problem, I'm going to use r because I have r up here, so I want to keep the variables the same. And I'm also going to have r here in terms of the area. So now, this is for the rectangle. So the surface area here of the total cup is going to be the area of the bottom circle, which is just simply going to be area of a circle is pi r squared, plus then the area of the rectangle, which we said was the circumference, times the height, which we said circumference is going to be equal to 2 pi r, times then the height. Okay, now, from there, I'm pretty much, I think there was something else I was going to say, but I can't remember. There is no top to the cup, and that's why I'm not including another area in this. Okay, but if it had a solid top, the only thing I would do is basically put a little 2 in front. Now, the whole problem is asking me to minimize the surface area, okay? So this is really my function of interest, all right? And this is the function that I'm going to wind up plugging into my calculator. Now what I'm going to do is I'm going to call the surface area y, okay? And now I'm going to start calling the radius x. So this would be pi x squared plus 2 pi x now times the height. Now the problem is I can't really plug this into my calculator because I have this silly old height here, right? I have kind of 2 unknowns on the right hand side, which is no good. I cannot use my graph. So I need to somehow get rid of the height. And that's kind of where now we have to go back and talk about the volume function. See, what I'm going to do is I'm going to solve this equation for height. When I do that, I have to divide out the pi r squared from both sides. And what happens is then it's 50 over pi r squared is equal to the height. Now what I realize then is I can basically just take this term and plug it on in for the height there. Now the beauty of that is I now have an equation here with only one unknown. Okay, so this is going to be 50 over pi r squared. So I have only one unknown now. All right, well, and also the r, remember, became an x, so I should really make that x squared. Okay, now with canceling and stuff, the pi's go bye-bye here. Okay, this x will cancel with one of those x's. I'm using x to cancel too, so that could be, I'd use a scribble. All right, and then you can kind of clean this up. 50 times 2 is going to be 100, and then you're left with x in the denominator. So this is just simply going to be pi x squared plus then 100 over x. Now this is the formula for your surface area. All right, now you still might say, what? I gotta minimize it. Okay, great. We have a formula for surface area that's a function of the radius. But now what? Well, this is where your super duper calculator comes in. Okay, so watch. I'm gonna plug the function in. So hit pi, all right, times x squared plus then 100 divided by x. Now, what you're going to do is you probably have zoom, you go to standard zoom 6, okay? And you probably see something like this, and you're like, all right, what do I do now? Well, first of all, I'm going to reframe this a little bit because I only want to see this quadrant over here. I only want to see quadrant 1 because those are where all of the positive answers will be, right? This kind of has a negative x value, which means it has a negative radius. What the hell does that even mean? Right? We're not going to bother with that. So instead, what I want to do is go to your window. Your minimum x is 0 because the radius cannot be smaller than 0, and leave the max at 10 for now. The scale, meaning every tick mark, will represent 1 on your graph. Leave that alone. Now the minimum y value, remember y in this case was the surface area. So you cannot have a negative surface area. The small surface area is 0. All right, and what I'm going to do is I'm going to bring this up to maybe 100 for now. Okay, and I'm going to scale it by 10. That means every tick mark will represent 10. Now hit your graph. Ah, look. So this is now, here's the function, all right? So now what I'm going to do is bring it on over here. And remember now, what we see is we have the surface area on the y-axis, and the radius is on the x-axis. Remember, this goes up to 10, and it went incremented by 1 unit. Okay, so this is going to be 1, 2, 3, 4, 5, etc. And now remember, the surface area said we went up to 100, and I incremented it by, is that a word? Sure. It went up by 10. So this is 10, no, yes, 10, 20, 30, 40, 50, etc. Okay, now, where does the minimum surface area happen? Well, it happens here, right? It happens at roughly, it looks like, what's that, 60? Right, minimum surface area of 60, 10, 20, 30, 40, 50, 60. And what radius will give us that minimum surface area? It looks like about 2.5, roughly. Okay, so that might be good enough if you just had to rough it. But if you wanted to get a more accurate answer, what you could now do is go to your calculator and use this thing, calc. So watch, hit second trace, because what that does is it brings up the blue function above that button, as you can see, calculate. And then we want to find the minimum of our function, so hit 3. Now, all you have to do then, it says, you got to do 3 things now. You got to be to the left bound, meaning move your cursor to the left of the minimum point, just somewhere to the left. Hit enter. Then move it to the right, somewhere to the right. Doesn't matter if it's, just somewhere to the right. And then guess, roughly. Don't waste too much time. Just say it's here. If you were a little bit off, call it. It doesn't really matter. The calculator is going to know what to do. And if we notice, we're right here at a minimum of 2.5153, blah, 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 blah. Okay? So what that means now, and as you can see, the y value is roughly 60. Okay, so this really isn't 60. It's really the minimum surface area, as we just found, is going to be 59.63. And the minimum radius now, which was x, is going to be, or not the minimum radius, but the radius that gives the minimum surface area is going to be 2.515. I'll leave it at that. Okay? And guess what, ladies and gentlemen? That's it. Okay? It wanted us to find the radius that will yield the minimum surface area or the lowest surface area. That's it. The lowest surface area is 59 point whatever. What radius gives that to us? 2.515. All right? If you all set to find the height now, let's just say hypothetically, all you would have done was use this function then, because it's already solved for height, and you can plug in your radius. You plug in your 2.515 in there, find your height, and bada bing, bada boom, as they say. All right? So thank you so much for tuning in. I really do hope this helps. We're here to help you. All right? Not only do we offer private tutoring, but we have some new membership program here where we respond to priority comments. We can also make custom videos for you. And we're constantly increasing our offerings to try to help you through your class. All right? Help you through your studies. We got physics, we got chemistry, thousands of videos out there to help you through, and actual solve problems, because guess what you're going to see on your test? That's right, problems. All right? So we got your back. Don't stress. Check us out. Take care.